Hey, let's solve some systems by graphing. Let's remember that if you have a system of two equations, there are three possibilities. There can be one solution, infinite solutions, or no solution. So the way that we do this for graphing is we graph each line and then we find its point of intersection. So I'm going to go ahead and graph this one. It's in slope-intercept form. So my y-intercept is 0, 5, and my slope is negative 2 over 1. Now also when you're doing this, make sure you're graphing accurately so you can find a nice point. Okay, so let's see. If I have 0, 5, 1, 2, 3, 4, 5, there's one point on my line. I go down 2 over 1, down 2 over 1, and I connect my dots. Again, I want to do this as accurately as possible so I can clearly see the point of intersection. Okay, then for my other equation here, this is not in slope-intercept form, so I can just select points. So I'm going to find the intercepts. The x-intercept is where y equals 0. So x minus 3 times 0 equals 6. So x equals 6. So my y-intercept, or x-intercept is 6, 0. For my y-intercept, this is where x is 0. So 0 minus 3y is equal to 6. Negative 3y is equal to 6. So y is equal to negative 2. So it's 0, negative 2. So I have 1, 2, 3, 4, 5, 6, 0, and 0, negative 2. And then I will graph this line. And lo and behold, I can tell since that they're going to intersect. But my solution, this is my solution where they intersect, which is the point 3, negative 1. Okay, notice I redid the grid. You don't have this grid on yours, but I did mine in advance. Okay, if I have x plus y is equal to 11, once again, neither of these are in slope-intercept form, but I can easily take this. If I have x plus y is equal to 11, subtract x, I have y equals negative x plus 11, which tells me that my y-intercept is 0, 11, and my slope is negative 1 over 1. So I have 0, 11, and I connect my dots. Okay, so let's see how we're going to do this other one. So if I have, I think I'll do the same thing. I think I'll put this in slope-intercept form. If I have 3x minus y is equal to 5, if I add y to both sides, I get 3x is equal to y plus 5. Subtract 5 from both sides, and I get y is equal to 3x minus 5. That tells me that my y-intercept is 0, negative 5, and my slope is 3 over 1. So I start at negative 5, go up 3 over 1, up 3 over 1, and see what's going on here. 3 over 1, 1, 2, 3 over 1. Oops. Okay, so let's see what I've got here. And just by finding the points, I found the solution. But the solution is this point of intersection here. So my solution is 4, 7. All right, again, for me, it's easier if I just uh, do it using slope-intercept form, but it's easy to do with the intercepts as well. But what I'll do is I'll take this equation and y plus x equals 3, so y equals negative x plus 3. That means my y-intercept is 0, 3, and my slope is negative 1 over 1. So 0, 1, 2, 3, down 1 over 1. I'm going to do it several places since they're so close together. Okay, then this one, I have y equals negative x. I'm sorry, y minus x is equal to 1. If I add x to both sides, I have y equals x plus 1. If I add x to both sides. So this tells me that my y-intercept is 0, 1, and my slope is 1 over 1. So I have a point here, up 1 over 1, up 1 over 1, and I can already see where they are intersecting. So that tells me my solution is where they intersect, which is the point 1, 2. Okay, now here it kind of gives you some leeway. It says that you can use any method, substitution or elimination, which is also called the addition method. I use the substitution method when it's easy to find one variable by itself. I use the elimination method. So here I would use substitution. Here I'm going to use elimination, also called the addition method. Here, since everything's nice and lined up, it's not going to be easy to solve for x. So this one I would do by elimination, and this one by elimination. So like always, when you get to the test, you need to figure out, have they told you to do something specific or not? All right, so here's what's going to happen. I'm going to take this first one here, and I'm going to solve for x. So this becomes x equals 2y plus 7. So now in this equation, I'm going to replace the x with 2y plus 7. So I have 2 times 2y plus 7 plus 5y is equal to 5. Okay, now I'm going to solve for y. So that gives me 4y plus 14 plus 5y is equal to 5. 9y plus 14 is equal to 5. 9y is equal to negative 9, so y is equal to negative 1. So I'm halfway home. All right, then I'm going to put this into this equation. I get that x is equal to 2 times y. I'm sorry, and that's negative 1 now. 2 times negative 1 plus 7, which tells me that x is negative 2 plus 7. X is 5. Okay, so I always want to write my solution as an ordered pair. So my solution is 5, -1. Now I have to remember my vocabulary. Is it consistent? That means it has a solution. Yes. Is it independent or dependent? Independent means they're different lines, so it is independent. Okay, so for B, these are all lined up nice and pretty. It would really be hard to solve for one of the variables, so I'm going to use the addition/elimination method. So what I need is either for the x or the y, I need the same numeric part of the coefficient with opposite signs. Since the y's already have opposite signs, what I'm going to do is I'm going to take this top equation and I'm going to turn both of these into a 6 because they're both divisible. I'm sorry. So I'm going to multiply this by 2 to give me a positive 6x. I'm sorry, 6y. So that gives me 8x plus 6y is equal to -2. And I'm going to multiply this one by 3. And when I do that, that becomes 15x minus 6y is equal to 48. Okay, so now when I add these together, this is eliminated. That's why it's called the elimination method. So this gives me 23x is equal to 46. Divide by 23, and I get x is 2. Then I just plug 2 into either one of the equations. It doesn't matter. So I'll do the top equation. So 4 times 2 plus 3y is equal to -1. So that gives me 8 plus 3y is equal to -1. When I subtract 8, divide by 3. Okay, so again, my solution as an ordered pair is 2, -3. There is a solution, so it's consistent, and it is independent, since they are not the same line. Okay, so I have 2x plus 7y equals 65, 21y plus 6x equals 19. Okay, now this was a little tricky. This can actually be written as 6x plus 21y is equal to 19. And of course, then this is 2x plus 7y is equal to 65. Now, this is a lot more manageable. And I will tell you the reason I saw that is because I thought, I don't want to multiply anything by 42. Okay, so here's what's going to happen here is it'll be easier to get rid of the 6's. So I'm going to take this and multiply it by -3, which gives me -6x minus 21y is equal to -195. Okay, so now when I add these two equations together, the x's are eliminated, the y's are eliminated, so I have 0 equals -176. This is not possible, so there's no solution. Now, what do we call it when it's no solution? We call it inconsistent because there is no solution, but we call it independent because the lines are separate. Now you could verify this by putting them in slope-intercept form, and they would come out with the same slope and different y-intercepts. Okay, so let's look at E. I have 3x minus 4y equals 1, 6x minus 8y equals 7. Okay, so let's see what's going on with this. Well, let's see here. I'm going to multiply the top equation. Let's multiply it by -2. Then that becomes negative 6x plus 8y is equal to -2. And this one just stays the way it is. So I have 6x minus 8y is equal to 7. So now when I add these together, that's eliminated, and I get 0 equals 5. Again, not possible. So there is no solution. And again, that means it's inconsistent. There's no solution, but the lines are different, so it's independent. Okay, and I think these are maybe a little bit out of order from what you have. Yeah, I think. Nah, they're the same. Okay. All right, 2x plus 3y equals 1, 4x plus 6y equals 2. Let's multiply this by -2. That'll give me a negative 4x and a positive 4x. So this becomes negative 2x, negative 4x minus 6y is equal to -2. This one is 4x plus 6y is equal to 2. So now when I add these together, this is eliminated, and this is eliminated. I get 0 equals 0. This means there are infinite many solutions. Basically, it means that they are the same line. So since there's a solution, that means they're consistent. They're dependent because they're the same line. Okay, so let's see what we're going to do on this one. All right, I have 7 times a minus b equals 21, and I have 2a is equal to b plus 10. Um, Again, this one was by elimination, and I think I'll do this one by substitution because I can easily turn this into b equals 2a minus 10. So now I'll take my top equation and I will replace b with 2a minus 10 is equal to 21. This becomes 7 times a minus 2a plus 10 is equal to 21. 7 times negative a plus 10 equals 21. Negative 7a plus 70 is equal to 21. So negative 7a is equal to negative 49. And I get a is equal to 7. Okay, well now I can combine this, and B is equal to 2 times A, which is, I keep doing that, times 7 minus 10. So B is 14 minus 10, which tells me that B is 4. So my solution as an ordered pair is 7, 4. When you're dealing with um, alphabet, just do it in alphabetical order. Okay, since there is a solution, this is consistent. The lines are not the same, so they are independent. This is a good place to stop.